That outboard motor on the back of your boat? It started as molten aluminum, heated to over 1,300 degrees Fahrenheit. Then it passed through the hands of more than 4,000 factory workers, across 3 million square feet of manufacturing floor, through machines that cut metal to tolerances thinner than a human hair. One completed V8 outboard rolls off the assembly line every 5 minutes. That's over 200 engines a day, and every single one of them carries the same hidden truth. Somewhere between the furnace and transom, between the robots and the quality inspectors, decisions were made. Corners were weighed, and your engine's fate was sealed before you ever saw it. The brochure won't show you this, the dealer won't mention it. But today, we're walking inside the factories that built the motor you trust with your life on the water. Now, before we go any further, quick question. Do you actually know how many hands touched your outboard before it reached your boat? Drop your best guess in the comments below. I read every single one. And if you haven't already, hit that subscribe button and tap the bell so you never miss another deep dive into the real stories behind the marine industry. Now, let's step onto the factory floor, and I promise you, you'll never look at your engine the same way again. If you've ever watched a manufacturer's promotional video, you've seen the version of outboard production they want you to believe. Gleaming steel, robotic arms moving with surgical precision, engineers in white coats studying computer monitors. Everything bathed in clean light, humming with the quiet confidence of technological perfection. Mercury Marine calls it precision engineering. Yamaha speaks of legendary reliability. Honda promises technology you can trust. And when you watch those videos, when you see the slow-motion shots of chrome components being assembled by machines that never tire, never make mistakes, never have a bad day, you believe them. You have to. Because you're about to spend $15,000, $20,000, sometimes $40,000 on the engine that will carry your family across open water. The global outboard motor market is valued at approximately $12 billion. By the end of this decade, analysts project it will exceed $16 billion. These aren't hobbyist workshops building engines in garages. These are industrial giants, multinational corporations with shareholders' quarterly targets and production quotas that would make your head spin. Mercury Marine alone employs more than 5,200 people worldwide, with over 4,200 of them working at their global headquarters in Fond du Lac, Wisconsin. Their campus spans more than 3 million square feet of manufacturing and engineering space. Since 2008, they've invested over $2 billion in research, development, and facility expansion. These are serious numbers, serious operations, serious business. And yet, here's what those promotional videos don't show you. The reality of modern outboard manufacturing is far more complicated than robotic arms and computer-controlled precision. Yes, there are robots. Yes, there are CNC machines capable of cutting aluminum to tolerances measured in thousandths of an inch. But the actual assembly of an outboard motor, the part where all those precision-machined components come together into a working engine, that's still done largely by human hands. It's called a hybrid model. High-tech automation handles the heavy lifting, the casting of aluminum blocks, the machining of cylinder bores, the cutting of gears. But when it comes to fitting pistons to connecting rods, routing wiring harnesses, torquing bolts to specification, installing seals and gaskets, that's where people come in. Thousands of them, working 8-hour shifts, 5 or 6 days a week, building the engines that end up on the back of your boat. An industry veteran once put it to me this way: people think robots build these engines. They don't. Robots cast the blocks, humans build the motors, and humans make mistakes. That's not a criticism, it's simply the truth. Every complex machine ever built, from automobiles to aircraft to the smartphone in your pocket, passes through human hands at some point in its creation. The question isn't whether people are involved, the question is how well those people are trained, how much pressure they're under, and whether the systems around them are designed to catch errors before they leave the factory floor. Because here's what the brochure doesn't tell you. By the time that gleaming new outboard reaches your local dealer, it has already lived an entire life you know nothing about. It was born in a foundry at 1,300 degrees. It was shaped by machines and assembled by workers whose names you'll never know. It was tested, inspected, painted, boxed, and shipped. And at every single step, decisions were made that will determine how that engine performs for the next decade of your life. So let's go inside. Not the showroom version, the real one. Let's walk the factory floor and see what actually happens before an outboard motor earns the right to carry you home. Every outboard motor begins its life on fire. Deep inside the foundry, aluminum ingots are fed into furnaces that heat them beyond 1300 degrees Fahrenheit. At this temperature, solid metal becomes liquid, a glowing molten river that flows like water but carries enough thermal energy to burn through flesh before you even feel it. Workers in heat-resistant gear stand 20 feet away and still feel the solid wall of heat radiating from the pour. Mercury Marine adopted a process called lost foam casting back in 2001, and it revolutionized how engine blocks are made. Here's how it works. An outside supplier creates precise foam patterns, not the kind of foam in your coffee cup, but engineered styrofoam molded to exact specifications. These foam shapes are dipped in a special coating, dried for 24 hours, then packed in sand. When molten aluminum is poured into the mold, it vaporizes the foam instantly and takes its place, filling every cavity, every channel, every intricate passage that will eventually carry oil and coolant through your engine. The beauty of this process is its complexity. Lost foam casting allows manufacturers to create single-piece components with internal geometries that would be impossible to machine from solid metal. But that complexity comes with risk. A single air pocket trapped during the pour, an invisible void in the aluminum, and your engine block could develop a crack 5 years from now. You'll never see it coming. The failure will seem sudden, inexplicable. But its origin was there from the beginning, sealed inside the metal on the day your engine was born. Not every casting gets X-rayed. The math simply doesn't allow it. When you're producing hundreds of engine blocks per day, comprehensive inspection of every unit becomes economically impossible. Manufacturers rely on statistical sampling, process controls, and the assumption that if the parameters are right, the castings will be right. Most of the time they are, but not always. From the foundry, the raw castings move to the machine shop. This is where computer-controlled cutting tools transform rough aluminum into precision components. CNC machines, computer numerical control, can cut cylinder bores and bearing surfaces to tolerances of plus or minus 1/1000th of an inch. That's roughly 1/4 the width of a human hair. At this scale, even temperature fluctuations in the room can affect dimensional accuracy. Why does this precision matter? Because an engine is a symphony of moving parts, and every component must fit with its neighbors exactly as designed. A cylinder bore that's even slightly out of round will cause uneven piston wear. A bearing surface that's a few 10,000ths too wide will create oil clearance problems. These aren't hypothetical concerns. They're the kinds of issues that show up in warranty claims months or years after purchase, traced back to machining variations that occurred on a single shift in a factory thousands of miles from your dock. The machining process happens in stages: pre-machining, qualifying machining, and assembly machining. Between each stage, the block is unloaded and reloaded onto different fixtures. Each transfer is an opportunity for error. Each setup requires calibration. And when production quotas spike, as they did during the pandemic boat buying surge of 2020 and 2021, calibration checks can slip. Machines that should be verified every 100 cycles might go 200. Tolerances that should trigger a stoppage might get a pass. The castings don't know the difference. They emerge from the machine shop looking perfect, their surfaces gleaming with the confidence of computer-controlled precision. But hidden inside their dimensions, invisible to the naked eye, the seeds of future problems may already be planted. The assembly line is where everything comes together, and where the gap between marketing and reality becomes impossible to ignore. At Mercury Marine's Plant 15 in Fond du Lac, the V8 outboard production line operates with a rhythm as relentless as a heartbeat. Automatic guided carts ferry components from station to station. Overhead conveyors carry power heads through electro-deposition paint booths, where primers are applied to seal out moisture and corrosion. And at each workstation, a technician waits with tools in hand, ready to perform their assigned task. Each worker has exactly 5 minutes. 5 minutes to complete their operation, whether that's torquing a bed plate to an engine block, routing a wiring harness, or installing a fuel injector. Hold up the line and you'll hear about it. The math is unforgiving. When the V8 production line runs at full capacity, a completed outboard rolls off every 5 minutes. That translates to 12 engines per hour, 72 per 8-hour shift, and potentially over 200 outboards per day when running 3 shifts. A V8 outboard passes through more than 200 assembly stations before it's complete. That's 200 opportunities for human excellence. and 200 opportunities for human error. A bolt torqued half a turn too loose, a gasket seated slightly off-center, a wire connector that clicks into place but doesn't fully engage. These aren't dramatic failures. They're the quiet compromises that happen on a Tuesday afternoon, when a worker is tired or distracted or simply rushing to meet the 5-minute window before the next powerhead arrives. 31% of Mercury Marine's production workforce are women, a detail worth noting only because it reminds us that these engines are built by real people with real lives. They drive to work in the dark during Wisconsin winters. They take lunch breaks. They think about their kids, their mortgages, their weekend plans, and then they go back to the line and build the motor that will carry your family across open water. Once assembly is complete, every outboard undergoes testing. At Mercury, engines are run in closed test cells, connected to diagnostic computers that monitor temperature, oil pressure, and RPM. The testing protocols are rigorous. Engines may run at wide-open throttle for extended periods, sometimes over 300 hours with modified propellers to maintain constant loading. Yamaha subjects each engine to a minimum of 20 to 30 minutes under load in water tanks, checking for leaks, vibration, and performance anomalies. But here's what testing doesn't catch: the slow failures. A seal that holds for 30 minutes but fails after 300 hours of real-world operation. A water passage where microscopic corrosion begins invisibly on day 1 and becomes a catastrophic leak 3 seasons later. A wiring connection that tests fine in a controlled environment but works loose under the constant vibration of a boat pounding through chop. Testing is a snapshot. It confirms that the engine works right now, under these conditions, for this brief window of time. It cannot predict the future. It cannot account for the cumulative effect of salt spray, ethanol fuel, improper winterization, or the 1,000 small stresses that an outboard endures over years of service. When you buy a new outboard motor, you're trusting a system. You're trusting that the castings were poured correctly, the machining was calibrated properly, the assembly workers were trained and focused, and the testing protocols caught any defects before your engine was boxed and shipped. Most of the time, that trust is well placed. The engines work. They start on the first crank, run smoothly for years, and deliver everything the brochure promised. But when they don't, when something goes wrong, the failure can almost always be traced back to this floor, to these stations, to the 5-minute windows and the human hands that built your engine before you ever knew it existed. There's a number that manufacturers don't like to talk about. It sits in spreadsheets, discussed in boardrooms, weighed against quarterly earnings reports and shareholder expectations. That number is the cost of quality, and every decision made on the factory floor is shaped by it. That Made in USA sticker on a Mercury outboard? It means final assembly happened in Wisconsin. But the starter motor might be from China, the fuel injectors from Japan, the wiring harness from Mexico, the electronic control module from a supplier you've never heard of, manufactured in a facility that's never been featured in a promotional video. Modern outboards are global machines. The average engine contains components sourced from 12 to 18 different suppliers spread across multiple countries. Mercury maintains manufacturing facilities in Fond du Lac, Juarez in Mexico, Suzhou in China, and a joint venture in Komagane, Japan. Yamaha and Suzuki manufacture extensively in Japan but rely on worldwide supply chains for electronics, plastics, sensors, and raw materials. This globalization isn't inherently bad. It allows manufacturers to source the best components at competitive prices, leveraging specialized expertise in different regions. But it also creates hidden vulnerabilities. When any link in that chain fails, when a supplier cuts corners, when shipping delays force substitutions, when quality control slips at a factory 8,000 miles away, the consequences flow downstream to the engine on your transom. Then came 2020. The pandemic triggered a boat-buying surge unlike anything the marine industry had seen in decades. Sales spiked 30 to 40% almost overnight. Suddenly, everyone wanted to be on the water, away from crowds, away from lockdowns, away from the anxiety of daily life. Dealers couldn't keep boats in stock. Manufacturers scrambled to ramp up production. But factories can't scale overnight. Experienced machinists and quality inspectors don't materialize from thin air. Training takes months. Institutional knowledge, the kind that lets a veteran worker feel when something isn't right, takes years to develop. So manufacturers did what they could. They ran extra shifts, extended overtime, and pushed production lines to their limits. Mechanics and dealers notice the consequences almost immediately. Warranty claims on 2022 model year engines began climbing. Problems that shouldn't happen on new motors, loose bolts, misrouted wiring, corrosion from improper storage started appearing with uncomfortable frequency. One dealer told me privately, "We saw things come through that made us wonder if anyone had looked at the engine before it left the factory." But the economics of cost-cutting extend far beyond pandemic pressures. They're baked into the fundamental mathematics of manufacturing. Consider the water pump impeller, a small rubber component that circulates cooling water through your engine. A standard impeller might cost the manufacturer $8. A premium impeller with better materials and longer service life might cost $12. The difference is $4. Multiply that by 500,000 engines, and you've just found $2 million. Which impeller ends up in your engine? You'll never know. The brochure doesn't mention impeller grades. The dealer has no idea which batch your motor came from. The only way you'll discover the answer is when the impeller fails, or doesn't. The same calculation applies to seals, gaskets, bearings, and corrosion-resistant coatings. These are the invisible components that determine whether your engine lasts 5 years or 15. They don't appear in marketing materials, they're not featured in promotional videos, but they're the first place cost accountants look when margins need improvement. Every manufacturer faces this pressure. Every production line makes these trade-offs. The question isn't whether cost-cutting happens, it's where and how much, and whether the savings are passed on to you as lower prices. So where does this leave you? The person standing in a dealer showroom, credit application in hand, trying to decide which engine deserves your trust. It leaves you informed. And in a marketplace built on marketing promises and brand loyalty, information is the only thing that truly protects you. Mechanics have a saying that's worth remembering. Avoid the first model year of any new engine. Let someone else find the bugs. By year 2 or 3, the factory has worked out the kinks. The assembly procedures have been refined, the supplier issues resolved, the design flaws corrected through engineering changes that never make the press releases. That first wave of buyers, they're essentially beta testers, paying full price for the privilege of discovering problems that will be fixed for everyone who comes after. Before you accept delivery of any new outboard, insist on a thorough pre-delivery inspection. Not the cursory once-over that happens in the back of the dealership, but a genuine mechanical examination. One experienced marine technician told me he finds issues on brand new engines straight from the crate. Loose bolts, missing seals, corroded fittings, wiring that's been routed incorrectly. These aren't manufacturing defects in the traditional sense. They're the residue of production pressure, the inevitable consequence of building complex machines at industrial scale. Understand your warranty, not just the duration, but the details. Most major manufacturers offer 3 to 5 years of coverage with extended protection plans available for purchase. But warranties vary dramatically in what they actually cover. Some are non-declining, offering the same protection on the last day as the first. Others are prorated, with coverage decreasing as the warranty ages. Some exclude corrosion. Others exclude electrical components after the first year. The fine print matters, and reading it before you sign is worth more than any salesperson's verbal assurance. Your dealer relationship matters too. When warranty claims arise, the dealer serves as your advocate with the manufacturer. A dealer with a strong reputation and solid factory relationship can often secure repairs that might otherwise be denied on technicalities. A dealer who's struggling to stay profitable or who lacks leverage with the manufacturer may leave you fighting battles alone. But beyond the practical advice, beyond the inspection checklists and warranty comparisons, there's a larger truth worth acknowledging. We want outboard motors to be built like Swiss watches. Precise, reliable, timeless. We want to believe that somewhere, master craftsmen are hand-fitting components with care that borders on reverence, building engines that will outlast us all. And in some ways, that vision isn't entirely wrong. There are people on those factory floors who take genuine pride in their work, who stay late to fix problems, who feel the weight of responsibility that comes with building machines people depend on. But outboards are also built like everything else in the modern economy. Fast, under pressure, shaped by economics as much as engineering. The same forces that give us affordable engines and constant innovation also create the conditions for inconsistency. The same systems that produce 200 motors a day also produce the occasional unit that slips through with a flaw no one caught. Understanding this doesn't make you cynical. It makes you realistic. And realism, in a marketplace built on aspiration and emotion, is perhaps the most valuable thing you can possess. The next time you fire up your outboard, consider this. Somewhere, months or years ago, a worker in Wisconsin or Japan or a factory you've never heard of held that power head in their hands. They torqued the bolts, connected the wiring, ran the final test. Their work, their skill, their focus, their fatigue is with you every time you hit the throttle. Outboard motors aren't magic. They're the product of systems, brilliant and flawed, innovative and cost-driven, built by people doing their best under impossible pressure. When you understand how they're made, you stop seeing just an engine. You see the truth. And in a world of marketing promises, that truth is the only thing that truly protects you.